going to give a little bit of background about Kirk. He's with the Fort Worth district, which is pretty much home base for him. He did go to school at, I forgot where he went to school here. Texas Tech, okay. So at Fort Worth district, he's the chief of the mechanical section, which fits him well because he's an expert in sustainable design and development, commissioning, U.S. Green Building Council LEED certification system, life cycle cost analysis, and energy modeling. So it all fits together with the presentation topic for today. He is a registered professional engineer, certified energy manager, and even more rare, he's a certified building commissioning professional. All of those things put together, just like I said, makes him eminently qualified for today's presentation. And with that, Kirk, would you take it away? Everyone should have the opening screen on your computer.
Okay, great. Thanks, Ned. Hopefully I can live up to all those all those expectations here. Excited to talk to you all about the energy conservation. This is a great one. This is one of the highlights that people think of when we talk about sustainability is conserving energy. So I'll just jump in. Like Ned said, this is usually an hour-and-a-half presentation when we do the Prospect 244 course. And really, there's a lot that goes into it from the UFC, from the SDD policy, from the ECBs, and all the other criteria. So there's a lot of content. It's going to be somewhat high level here, just because finding time to drill down in all the content can be pretty difficult. So I'll start out with our objective here is to summarize the strategies to comply with Army energy conservation requirements. So it's a pretty straightforward objective. We're gonna talk about some of the strategies. We're keeping it somewhat high level, like just mentioned, but we'll be happy to take questions in the chat. Like I said, we'll try to circle back around and catch those towards the end, just time permitting. So appreciate y'all joining in, and hopefully it's a good presentation here. So start off real quick with some of the resources. For those of y'all that have been attending the webinar series, a lot of these will look really familiar. The UFC 1202. We have our team site, which is where all the slides are going to be uploaded, as well as the recordings. We have the International Green Construction Code, the criteria formerly known as 189. We have the ASA SDD policy, that's the 2017 version. And then as well as the LEED online. So we'll talk a little bit about LEED on this, where we come across, but it's not a real LEED heavy presentation. More kind of some things that kind of keep in mind as you're kind of more probably project planning than anything. So we won't get real LEED heavy for y'all. So in this presentation, it's structured around UFC 1202. Specifically around chapter 2-3, where we're talking about optimized energy performance, and the topics that are covered in that section are energy efficiency, energy efficient products, standby power devices, on-site renewable energy, metering, and then compliance documentation. So that's what you're going to find when you get into the UFC. This presentation is trying to give a high level of all those. And you can kind of see by the 6 items listed there that you can drill down pretty deep into each one of those individually. With the content, there's a lot that can go into these. So I'm from the kind of training where I like to open up with some kind of funny. So here is Garfield talking about energy conservation. Enjoy just kind of starting off on a lighter note here. While y'all are enjoying that, just kind of give you a couple interesting facts here. Offices, hospitals, schools, supermarkets, factories, and others account for nearly half of the energy consumption in the United States at a cost of more than $3 billion per year, which is more than any other sector of the economy. Out of all that energy, up to 30% or more is wasted through inefficiencies. Improving energy efficiency is the single largest way to eliminate this waste. With more than 350,000 energy utilizing buildings and 600,000 vehicles, the federal government is the largest energy consumer. So that's coming from energy.gov, but just some facts as to why energy conservation is a big part of our sustainability. Is it's a big user. It has a big impact on the cost, as well as it's a great place to start if we're looking at minimizing waste. So, like to start out the conversations with just a quick kind of overview of policy and kind of the hierarchy with policy. We're going to kind of talk about some of these in various levels. So, just kind of wanted to help give a little crosswalk here at the beginning. You know, with design, we're required to follow all of the different policy and criteria that are dictated down. So at the highest level, you have federal laws and executive orders, and then working your way down towards the engineering construction bulletins, which are USACE. And those are really there to kind of fill as a stopgap, because there can be a significant amount of time for some of these things to happen, depending on the way things work. So a lot of times people that are familiar with design are used to seeing a lot of these, and kind of where you're at, kind of with some of that depends on how familiar you are, but hopefully, you know, the ECB level, the USC 1202 level, the Army Sustainable Design Development Policy level are familiar things for those that are in design, and we are familiar with a lot of that criteria. So just kind of high level crosswalk, we're going to hone in, as you can see with the red circle, primarily on the UFC 1202. We, you know, kind of mentioned that we wrote the training around that, and we're working towards the energy chapter for compliance. So jumping right in with this, I'm going to just kind of give you a little disclaimer up front here. These are my interpretation of the policy highlights. You know, it's certainly not everything that's in there, and that, you know, really the best way for y'all to get to know what's required is to read the policy. So as we're jumping through these, I tried to pick out a few things here to cover, and hopefully they're good for conversation, hopefully good knowledge, but I strongly encourage those, especially in design and enforcement of design, to read the policy and know what's in the criteria. So here with our energy efficiency, we can see that if with this section, commercial and multifamily buildings, we're going to be achieving ASHRAE 90.1, and so there was a great presentation previously done on 90.1 2019. I will say all of these slides are written around the current policy, which is 2013. So kind of get to apply some of that. Thankfully, getting to have some of that knowledge share. It was a great presentation on the 2019. So there will be quite a few changes that are happening, which is part of why they did the presentation, to share that knowledge. So some of the items from this, you know, where we have the 2013 would be changing. So with this, we're, you know, typically if we're a commercial or multifamily high-rise building, we are following ASHRAE 90.1. Just kind of a caveat here, 90.1 does not cover low-rise residential. We'll pick that up a little bit further on, and that's defined as 3-story or less kind of dwelling units. We're going to base our energy efficiency design decisions on life cycle cost analysis, and there's a whole nother presentation with that one, so I'm not going to go real far down that one. I believe that's next week, and we'll touch on LCCAs. Another highlight that I wanted to kind of point out in here is we're providing 3 alternatives with our LCCAs, and we're comparing against an ASHRAE 90.1 baseline. So just kind of, like I said, highlights that I wanted to pull out of there. We're going to meet the requirements of 90.1 2013. And there are footnotes with some of this that dictate talking about the compliance methods. And so for those of y'all that might not be as familiar with 90.1, this image is actually a screenshot of the HVAC section. And you can kind of see as you get down here, there's actually multiple different paths that you can kind of work your way through with a prescriptive or an energy cost budget. So there's different kind of methods with that. You know, we are supposed to be fully compliant. So you can kind of see, I'll say a lot of our buildings, we end up going through the energy cost budget method, section 11 or the PRB method. More specifically, but we'll touch on that a little bit further, but just kind of the high level here is that we are going to comply with ASHRAE 90.1 2013. A lot of people are familiar with that. We're doing our LCCAs to document our design decisions. We're providing those to kind of further support, you know, the assessment that we do during design. So a continuation here on the energy efficiency. So we're designing the buildings to achieve at least a 30% energy consumption reduction. If 30% isn't life cycle cost effective, then we're working to achieve the highest level of energy efficiency that is life cycle cost effective. So just kind of wanted to crosswalk a little bit here from some of the other criteria that's out there. So the ER that's listed here states that where similar performance is achieved, we're going to select alternatives. We're going to select the most economical. ECB 2020-8 states, you know, that we're selecting alternatives for the analysis. We're going to give a preference to features and systems with lower complexity and maintenance burden. So finding, you know, the perfect fit across all of these different can be difficult if, you know, we're trying to find the highest energy efficiency as well as the most economical as well as the lowest complexity and maintenance burden. Sometimes those may not end up all looking like the same thing. So I believe there's some rewrites on some of this, but just kind of wanted to point out some of these. But you know, per the UFC, we're going with highest level of energy efficiency. A key point that I want to kind of put in here is the reminder for people. LEED uses energy cost savings. So as we're going to go forward with some of these slides, you're going to see there's a difference between the energy consumption reduction, which is what our UFC is calling out, and LEED's energy cost savings. And the kind of the big caveat here is the energy cost savings is actually based on your utility rates. And so they don't directly align with the consumption reduction. So those of you that are all familiar with it will probably know that, but kind of one of the things I wanted to kind of help point out here was that there is kind of a different unit here. And so as people are looking at these things to keep that in mind. So here we can see the equation for what the UFC calls out for determining our percentage of improvement. So the 30% savings that we're striving towards. There's some factors that go into how you calculate that out. This is an important thing to note, especially when you're doing your compliance paperwork, making sure that you're using the right you're using the right units and that you've taken out the pieces that are supposed to be reduced out for your reporting. Not going to go real deep into this one. Actually got some better slides here to kind of show a little bit of the difference. So real world example, wanted to try to give some of those. Most people that deal with HVAC analysis and or energy modeling are familiar with TRACE. That's primarily what we use in our district. So kind of wrote these around TRACE. The eQuest users and others, sorry, we're going to use TRACE pictures. Here, just kind of wanted to highlight kind of what it might look like when we're trying to show our ECB/PRM summary, also known as our percent savings for energy consumption. So here in the red box up top, you can see that we had a baseline and kind of a proposed, and hopefully our total building consumption is lower with our proposed. You can see that it was an air-cooled chiller being compared to the 90.1 baseline. And then below that, you can see the the summary from the lead summary report, we can see that we're getting 25% energy saving or energy cost savings with this reporting. So jumping over to the next one here, I kind of wanted to highlight this for a lot of people because this can tend to be a big confusion, is our energy consumption reduction, per the UFC method. If we did the math with the equation that I showed y'all before, we come out with about 45% energy savings when we take out our plug load receptacles. What we get with our lead energy cost savings is actually 25%. So sometimes, early in project planning, we end up, wanting to start filling out our lead scorecard, and then people say, hey, we're going to get 30% energy savings because we're going to meet the UFC, so we must be getting 30%, per lead, so we're going to get X number of points or credits. What you can end up with, and especially those that have done energy modeling and kind of lived on that side, is we're not doing apples and apples. And that here's kind of a prime example of, you can be saving 45%, but only getting 25 with lead. And so for those of y'all that have lived through lead, you can know that losing credits, especially right out the gate, can be really hard to make up. So just kind of a highlight for y'all there is, just because it says 30% in the UFC does not mean you can just go straight to your scorecard and mark 30%. So just got to know that it's going to vary depending on your utility. Our area where we're at, we tend to have lower utility cost, which kind of a little bit work against you when you're doing things on cost savings. But it varies throughout the country. So we're kind of countrywide, nationwide here. So very much look at your utility rates. Just kind of the plug is don't just assume 30% right out the gate. So keep moving on here. So here we're gonna determine our energy consumption levels for our baseline and our proposed. So here we're talking a little bit more about the performance rating method. For those that are familiar with it, this is your ASHRAE 90.1 Appendix G. So this is really what's telling you what your buildings are going to look like for when you're modeling. And so not to go way too deep down that road, but essentially anytime where we're going to model our building for UFC compliance, for LEED, for the credit, we're probably going to be pulling Appendix G. And learning from the 2019 ASHRAE presentation, it sounds like a great thing is that the baseline is actually going to start being fixed. As an energy modeler, that makes me really happy, because one of the hardest things is trying to figure out, you're trying to model this baseline as well as model your proposed building. So it sounds like they're trying to make things a little bit easier. Look forward to doing some of that and kind of learning going forward here. So just one other highlight for kind of this slide is typically, if we're working a LEED model, you will end up with at least several kind of model variations. So the first one is typically your proposed against an ASHRAE 90.1 2013 baseline, and that's for your UFC compliance. And then if you're doing LEED version 4, you would be doing a proposed versus an ASHRAE 90.1 2010 baseline. If you're using version 4.1, it looks like it's a 2016 baseline. But there's a lot of information out there for those that do modeling. So just make sure you're using the right baseline is kind of the plug that I'll give there. And that, yes, there might be a need for several models to make sure that we're fully tracking the UFC compliance versus the other requirements. So a little bit on residential. We're not going to go real far down it, but wanted to at least make sure that we covered some of it. we're not using 90.1 for our residential because it doesn't cover low-rise residential. So that's a big point. So we are going to meet the requirements of the International Energy Conservation Code. There may be some buildings, have a note kind of in here about there may be some buildings that are kind of an odd fit for some of this. So sometimes our large barracks are 3 stories and less, and so they actually kind of fall into the dwelling unit or residential kind of criteria, but they're not a great fit for the Energy Conservation Code. So I'll say there may be some areas where some of this can be a little bit difficult. You may be looking at LEED for homes. A lot of times what I've seen is people still apply LEED new construction and or they apply 90.1 for some of these cases, and they kind of just have a higher standard on their baseline. But when we're dealing with kind of normal low-rise residential, we're working with the International Energy Conservation Code. We're going to have a similar requirement where we're going to achieve 30% energy consumption reduction from the IECC. Once again, if we're not hitting that, we should be doing the lowest life cycle cost effective that has the highest energy efficiency. Yeah, and so and we should have our LCCAs to back up that documentation. And so here, talk a little bit about renovations. There's a lot of variation with renovation, so going to keep it real high level. But with the UFC, it talks about kind of the different levels of renovation, and the first one it begins with is replacing everything above the foundation, and that's where you kind of see some of this start to build in, and you have kind of these choices. If we're doing everything above that, that means we're more or less keeping the structure, and then for you with that, you're going to apply the new construction requirements, and if you're doing a variation of that, then you get into other ways for determining. And so the first one's kind of listed here for kind of documenting your savings, or what this is really showing is the first 2 are actually using metered data. So we're defining our baseline, by measuring the building energy use against a baseline. I'll say historically we've had a hard time, getting as-built. So, asking for baseline data, that's usually a pretty tough go at getting in actuality. So usually what we end up seeing is option 3 here, where we're reducing the modeled energy use by 30%. Here we can see that, if we're in a renovation, we're using ASHRAE 90.1. If we're commercial or multifamily high-rise, we're using the IECC if we're residential. So it's pretty similar, nothing too drastic from what we saw with the new construction there. So jumping a little bit into energy efficient products. So the UFC calls out that we're gonna provide Energy Star qualified or FEMP designated energy efficient products. And so these are Energy Star is an independently certified product that shows that it's going to provide energy savings. So a lot of people are probably familiar with that. With the water presentation, we talked about the water sense label. These are products that are showing energy savings above a normal baseline. And then the FEMP, they work with stakeholders to enable federal agencies to meet the energy-related goals, providing solutions to provide energy leadership, the country by identifying best practices. So put some links on here. For some of these. There's some great tools on there. Really, I had a lot of fun digging around on the FEMP website because they actually have some really cool tools on there. They have an alternative water source map. They have a rainwater harvesting calculator. They have some pretty cool kind of things out there. So encourage y'all to look around at some of those. Here, just kind of talking about the graphic is just kind of breaking out the federal government's energy consumption levels by fuel type. Just thought that was there's some great data out there on some of these too. If you're into site and source, kind of where some of this power is coming from. So pretty cool data out there. So encourage y'all to take a look at some of those links. So another criteria out of the UFC, it discusses standby power devices. So we're going to try to provide commercially available off-the-shelf products that use no more than 1 watt in their standby mode. It does call out life cycle cost effective, practical, and performance is not compromised. So this is want to give a shout out to the New Orleans district USACE office. We were down there for the mechanical COP meeting and took a photo because that's the kind of thing you do when you teach classes is you take photos of things that are good and bad. And so this is a prime example of good. Is they have a I think it's called a miser controller on their soda machine here that turns it off when they're not going to actually be in occupied mode. So trying to save that electricity, not keeping the soda cool when no one's going to be around to buy it. So shout out to New Orleans District for being energy conscious there. And it's kind of real world applications here of where we can save energy. Looking at with our occupants and things like that. So there's a lot of potential out there. I think a lot of people are familiar with, occupancy sensors on power strips and things like that, and just kind of the little steps that you can take that can actually add up to be a pretty big benefit, especially when looked at over years, of implementation. So on-site renewables. So here out of the UFC, we're going to provide on-site renewables. Here's a reference to the IGCC. So once again, this is the criteria that was formerly 189. Here for Army projects, we're going to I guess for all projects, we're going to do it where it's life cycle cost effective. So this should be one of our life cycle cost analysis that we're providing here is looking at on-site renewables. For Army projects, if it's not life cycle cost effective, then we're utilizing a section of the IGCC, which talks about on-site renewable energy systems for future installation. So there's a lot that can go into this. Once again, kind of a real brief, high level. It's not real clear or direct on kind of when you end up not having it be life cycle cost effective, as far as what level you take the future planning. So I've seen good examples and bad examples. So, a prime good example that I've seen with this is, you have the designer more or less put together a bid option for the package that covers, kind of the on-site renewable. So, showing a plan with panels on the roof for, a location for, a battery or things like that. So they've actually, taken it to the design level that it could be executed as a bid option. That's great planning. The really poor planning I've seen is you bring this up and then someone says, yeah, I'm sure there's a storage closet somewhere where you can throw something, so, it can be a little bit subjective, but just kind of staying with the requirements here of, per our Army policy, we should be building in some future capacity if we're not seeing it to be life cycle cost effective. Just want to highlight that, we're not purchasing renewable energy certificates per the current guidance. So, don't take those project dollars and go buy a lot of credits. And so then just a real quick highlight on the IGCC. So there's actually a couple of different approaches for compliance on there. There's the standard renewable approach, and there's actually an alternate renewable approach. So the standard renewable approach highlights, some of the highlights on that are it's going to contain on-site renewable energy, and it's going to provide, and it basically has a power factor per square foot if you have single story or multi-story. And it has some exceptions. You know, if you're in an area that has a average incident solar radiation less than 1.2 kBTU per square foot, you know, if you're accounting for an existing building or permanent infrastructure that's not part of the building project. So if you've got trees or, you know, something like that. So there's some rules that go into it. Once again, not trying to get real deep in this, but just kind of highlight that there's a standard approach, and then there's actually alternate approach. And the highlights from the alternate approach are here, where you can actually, similar to what we do kind of with our energy modeling, is you can apply, you know, Appendix B equipment efficiencies. You can have a more efficient water heater. You know, there's some Energy Star requirements, and what you'd see is that the values will actually change a little bit. So, and then the graphic here is of the KWH solar map for kind of the U.S. So just there's a lot of depth that goes into that. I'd say, you know, as you're kind of planning for this, you know, reading the policy, reading the criteria, getting familiar with it is definitely a must. So next one is solar domestic hot water. So we are going to meet at least 30% of our annual domestic hot water with solar domestic hot water. This is coming from ESA. Big one is unless it's not life cycle cost effective caveat. So a lot of this, I mean, I'll say a lot of times we're not seeing it be cost effective. That, you know, obviously it depends on where you're at in the U.S. It depends on your utility rates. It depends on a lot of factors. Did want to highlight out of this some criteria from the ASA STD policy. They want you to look at higher percentages than just 30%. So the preference is, you know, look at 30, but, you know, if 35% had been cost effective, then, you know, it's valid to look at that. So, you know, 30, you know, usually kind of what I have my team do is, you know, they look at 30, 60, and 100, and you can kind of see, you know, if you're going to have a cost effectiveness that kind of falls in those brackets, and you can kind of highlight in there. Obviously, you know, working towards the intent of trying to provide solar water heating production, but working with the life cycle cost effective requirement. So just kind of a plug for that of, you know, 30%, you know, what we're working towards, but, you know, it good practice is to look at other percentages and try to work towards, you know, implementing the technologies. So jumping into metering, once again, not gonna go real deep in this. The highlight that I'd point out is, you know, if we're working towards energy conservation, and y'all probably heard me say this with the water, is, you know, the best way to know if we're conserving is to actually be able to meter it. And so we should be metering our utilities that are coming in. I'll kind of give you the same plug that, you know, as a mechanical engineer, I love two things. You know, I can never get enough of two things: of isolation valves for turning something off when things don't go well and it actually needs to be shut off, and meters. So that way, when things are running and if we're consuming more than we expect, then we have the data to be able to try to break it down. And then that gets into sub-meters as well. And so a lot of people that are familiar with LEED are going to be used to dealing with sub-metering and things like that. And sub-metering is mentioned in the ASA STD policy. And so it can really be valuable, especially, when you're trying to go back in and look at buildings and actually trying to, do baselining if you were going to go a baselining method, and measurement verification. You're gonna really need these meters, and you're gonna need them to be broken out so that way it's not just one giant chunk of what the energy was. So big plug for meters. Very, the cost to benefit ratio is really high, and in my personal opinion with those. So a couple of highlights from the UFC with metering. We're installing an advanced utility meter. We're monitoring the building energy and utility consumption. There is a DoD metering policy. There's a link to it here. So recommend that. And then just kind of a big plug for, metering. As we're doing this, we want to be cybersecurity compliant. So we obviously don't want someone hacking the system through the smart meter. So please provide your cybersecurity. Put the reference to the UFC on there. A big plug for that, as well as any of the controls. But yes, we should be seeing these, and these work well towards achieving LEED credits as well. So this is another guiding principle that really the UFC compliance really trickles down into helping you get LEED points if that's the rating system you're working with, and it provides a real benefit later on with especially metering. So probably tired of hearing me harp on providing meters for your buildings, but it's a big part. So here we're going to we're starting to round out. We're rounding third, heading for home here, so we're actually doing pretty good on time. Here talking the UFC requirements for the compliance documentation. So here you would actually be going back towards the latter part of the UFC, going back into Chapter 4. And here we have an energy compliance analysis, or ECA, and we have some requirements that go into that. So we should be including with our ECA, it's in the design analysis that it demonstrates compliance with the energy related requirements in the UFC. So that's hopefully our energy compliance analysis shows that we're compliant with the energy policy. So that's a good starting point. Another highlight that I just kind of want to put in there is we should be including a summary of all the input and output from the calculations, and the calculated energy consumption of the baseline and alternative. So hopefully providing the kind of input documentation. I'll say, if you're working in a trace program or whatever, this is where you populate a couple hundred pages of reports essentially, or the input values. But these can be good, especially if you're trying to look back and see how things are modeled. I'll say, if you're working with an outside A&E firm, getting the entered values to see what they put these things in there is really valuable to be able to cross-check, the quality of energy model that you're receiving. And then just kind of a highlight, the program should be capable of performing a full year, or 8,760 hour calculation. And it talks about eQuest here, a lot of, there's obviously other programs out there, but just kind of that should be performing that full year. And those that have done modeling for LEED know that's another requirement that they're going to push, especially if you're trying to get a building certified with the energy model. So continuing on with the documentation, we should have an energy conservation narrative, or an ECA narrative. And we should have some statements in there discussing the energy from the architect, mechanical engineer, and the electrical engineer. They should be talking about, the features that were considered, the conservation measures that were adopted in the design. They should be providing the support LCCA calculations, and the decision making behind the LCCA. So we saw through this presentation, there was quite a bit that was dependent on your LCCA results. This is really the designer coming back and somewhat writing, here's the things that we analyzed, here's our thought process, here's the analysis that we performed. I believe it's a good idea to have a summary of results of, here's how these things fell out, to get to the point of the system that we're seeing, probably on the planning specs. So it's a great thing to show that, we didn't just, that we put our thought into our design, that, we were working towards being energy conscious, here's the list of things that were considered. And a lot of the designers are doing this. I'll say probably the hardest thing is stopping and writing down, all of these things that you've actually, considered and analyzed. And so a big plug for doing that, especially, as, we're looking at, did we consider things for our life cycle cost analysis? And, plug for the LCCA one, we'll talk quite a bit that you heard that a good bit here. So the follow on next week will be the LCCAs. So kind of in recap and summary here. So with the optimized energy performance, we were looking at, the energy efficiency requirements, what the energy efficient products, we didn't get real deep into, the product showcase or anything, but we saw the requirements, that we're going to be looking for Energy Star, we're going to be looking for reduction in standby power, things like that. We talked briefly on Onsite Renewables. That's a whole wide category that can be done there, as well as metering and the compliance documentation. So big plug for taking the sustainability prospect course. Like I said, we cover this in a slower format and try to get down into some of the actual product showcase with those. So I think we may have gotten it down into 45 minutes. So I'll pull it up for questions here.
So Kirk, did you want to run through the chat for questions yourself, or would you like me to post some to you?
Yeah, sorry, I'm pulling up the chat right now. I had it in, so I think I've got them all here. So, okay, so we have one from Kathleen on, isn't the federal government going to ASHRAE 90.1 2019 starting this next year? So my understanding from attending the webinar also is yes, that we will have 2019 coming. Haven't seen it directed yet. But yes, once again, we kind of wrote this webinar based on the current policy. So 2019 is likely coming based on the other webinars, and currently we are doing 2013. 2010 for those of y'all that are doing lead version 4. So Jim had one on if ASHRAE 90.1 compliance is not life cycle cost effective, is compliance still required? I will probably have to check and resolve on that one. I will say usually that's your baseline. So I don't know about your baseline being less compliant. So I'll say usually that's what you're grading against. And so, so I'll say probably not, that if nothing else, you should be doing ASHRAE 90.1 compliance, and probably not less than that. But sorry, it took me a while to read Daniel's there. Yeah, Daniel, I'll let you. I'll let you write that one up in your ECA analysis as far as looking at the alternatives there. So we had another one from William here about what happens with stormwater runoff. That is a lot of impervious surface area.
That was referring to the PV area if you have renewable energy.
Okay. Yeah, I mean, I'll say, obviously, with sustainability, trying not to look at, the best, sustainable solutions are ones that plug in well with other pieces. So, obviously balancing your site water requirements with your energy requirements, working towards, kind of that's part of why we have an integrated team is, getting all the key players at the table early. So that way, these kind of conversations could happen in design. That's kind of the plug I would give for that is normally with our, we would talk integrated design and talk about, how, kind of project planning up front and some things like that.
If I could add to that, Kirk, not having any specific DoD examples, some outside areas or some outside PV installations have had gutters, but other than that, some have been on gravel, which is not a good idea in some respects. Others have better infiltration because if they're put on ground that's no longer tilled, the infiltration generally goes up. And so the runoff hasn't been an issue there. So it's impervious from the panel standpoint. Also, it's sometimes panels are single or dual axis, changing to impact how much solar gain you can achieve instead of having static panels that are not necessarily in the peak when you want the peak energy from them. And those would distribute the water differently and sometimes actually change positions if there's a storm coming to help protect the panels. So from that standpoint, not responding to the impervious areas from the roads and everything else that you added on later. Over.
Okay, great. So just kind of scanning some of these other kind of statements in here. So Blaine, it looks like looking for examples of LCCA, ECA, some of the kind of what looks right documentation. We'll cover a little bit on the LCCA, especially a little bit on the whole building with some of that requirement. Yeah, I mean, those can be out there. Like I said, try to kind of really abbreviate this presentation because there's a lot of content. But yes, I'll say kind of a plug for the sustainability course, and then if you want to email the sustainability POCs, myself included, if there's something looking for, we can kind of help you find an example.
Could you put it on TED or 10 so that we know, so that everybody can go and see what right looks like?
Yeah, I mean, we can. I think probably, there might be some people that there may be varying for, there's not a, necessarily a USACE kind of template on it. So, it might be kind of like these slides of a little bit instructor subjective, of here's what right looks like. You get different products from, AEs and things like that. So, but yeah, I mean, really the criteria is going to be what dictates it. So, if you're, like for your ECA, for example, if you've provided your narrative and it talks about, the analysis that you've performed and you've provided your LCCAs and things like that, can obviously provide, examples from a design analysis, but, checking off all the items from the criteria is what would be good.
I mean, as a designer, it gets very frustrating because you say, well, I use good engineering judgment and I document it by good engineering judgment. And somebody comes behind you and goes, well, you can't do that with good engineering judgment. You got to do calculations, and that's subjective. And then I don't have anything to point to that says, well, this is as far as I need to go. And so that's all I'm kind of looking for is saying, hey, something that points to it and says, hey, I can say, well, I kind of know that I don't need to go that deep, and I only need to look at, the types of windows in the building, and I don't need to look at the size of the windows in the building, and I don't need to look at the placement of the size of the windows in the building. From an HVAC standpoint, I can just look at the R value and a nominal size of a window. You know what I mean? Because I can.
Yes, and I'll say I think those requirements might look and feel different depending on your projects. As if you have because what we're kind of talking about here is a lot of it is the UFC kind of compliance, but you may have some projects that have a more aggressive sustainability goal. The USACE Seattle office is a prime example, or you have a showcase building or something like that where you might be looking for some of those. And so, but yeah, I mean, if you want to reach out, I can help kind of give some examples. Like I said, with the LCCA one, yes, there are some real examples in the slides on that one with that.
All right, thanks.
And so Raymond had a question on the sustainability course. I believe there's one in Huntsville. It's been a little while since I've looked at the schedule, and then I believe there's one in Seattle this year. So we are working to get that up and rolling again. So I'd say probably refer to the Purple Book schedule would be better. It might be on the sustainability team site as well. I'd have to look around on that one.
It was end of July for Huntsville, and I forgot which date, some middle towards the end of August for Seattle. We don't have a schedule for next year yet. It's only 2 courses, as Kirk mentioned, this year.
Sorry, trying to catch up here. So looks like Raymond had a question on demand control ventilation still allowed per the UFC. Are CO2 sensors still allowed? Yeah, so I think that's actually going to be per the HVAC UFC. I'm going to kind of work off of memory here, but I believe, yes, we are still allowed to do demand control ventilation, and that's encouraged as an energy savings. I believe the CO2 sensors per your, Army, kind of guidance, I believe that is, you can use CO2 sensors if you have authority having jurisdiction approval. I'll say, building scheduler and occupancy sensors, obviously they don't go quite as deep, but that is one method. Yeah, and it looks like Sven picked that up also. There we go. So. Okay, so it looks like Patricia answered on the ASHRAE 90.1, so thank you. Yeah, and so yeah, talking about the CO2 sensors, yeah, they do have a tendency to kind of drift on you there. Okay. Yeah, a plug for Seattle there from Dan. Yeah. So yeah, overall, I'll probably go ahead and just wrap us up here. And so appreciate everyone calling in. Hopefully, we were able to answer some of the questions, or maybe even spur some more questions for the energy conservation. Like I said, plug for getting in there and reading the criteria and handling that.
And with that,
Can we, is there a way to get a copy of the slides?
Yeah, so they're going to be on the sustainability team site. That's where all the slides are getting uploaded.
Okay, great. Thank you.
Okay, well, I appreciate everyone calling in. Thank you.
And with that, we'll shut down. We'll just leave things up for 2 more minutes to capture some more chat if somebody's entering something at the last minute. Other than that, thank you, Kirk. And we'll see everybody next week, or hopefully next week. We had a peak of about 136 folks on today. So great. Signing off here.